Okay, so today we're going to be talking about how to prepare solutions, but first we got to practice how to use molarity as a conversion factor. So I have this practice problem pulled up for us to work out together. And so this practice problem reads, how many liters of a 0.14 molar NaOH solution are needed to have 1.24 moles of sodium hydroxide? And so go ahead and pause the video and give yourself a moment to try to come up with the solution yourself. All right, let's talk about this problem. Every time you see a molarity or other unit of concentration in a problem, you need to think to yourself, that must be a conversion factor. And so this means the definition of molarity, which is what the M is, the capital M, is moles of solute per liter of solution. And so my solute in this case is NaOH. And that'd be moles of NaOH per liter of solution. That's the definition of the M. Now we need to add in our numbers. Now this number belongs in the numerator. And then any number divided by 1 is itself. So if you typed into your calculator 0.114 divided by 1, you would end up with 0.114. So that's what that's telling us. Now that it's written in a conversion factor format, we would be able to flip it upside down where liters would be in the numerator if we needed it in that orientation for units to cancel. So we are being asked to find liters. So we'll make a map for ourselves. Find liters given moles of NaOH. Find liters of solution. Now, since I see liters of solution and moles of NaOH, my conversion factor between those are going to be my molarity used as a conversion factor. So I can go ahead and start setting up my problem where we have 1.24 moles of NaOH. I need to cancel out my moles of NaOH, and I need to get into liters of solution. So when I look at my conversion factor, I did not budget my space well. That's my moles, and that's my 1 liter. So I am just looking at my conversion factor that I came up with earlier. So then I can type that into my calculator, and I have 1.24 divided by 0.114, and that is 10.877 liters of solution. Now, when it comes to sig figs, I have 3 sig figs in my molarity. I have 3 sig figs in my moles. And so I can count 1, 2, 3 significant figures. That's a 7, so I'm going to round up. And so my answer that I'll report is 10.9 liters. And of course, there is math typed underneath. And so if you were looking at the actual PowerPoint presentation, you'd be able to see the math underneath. Another thing to note is that strong electrolytes completely separate in solution. And so that's the definition of strong electrolytes, is that they completely separate into ions. And so if you have a strong electrolyte in solution, it's going to break apart into ions. And so if you have an ionic compound, any kind of ionic compound, or a strong acid, strong base, it's going to completely ionize. So they dissociate. And so this is a calcium nitrate solution. And based on the chemical formula, the subscripts for calcium is 1 and the subscript for nitrate is 2. And so when this splits apart in solution, for every 1 calcium I make, I'm going to have 2 nitrates. And so in this box, since I have 2 calcium, that means I have to have twice as many nitrates, and so I have 4 nitrates in the box. It's always a 1 to 2 ratio between those ions. But we can also use these subscripts in the chemical formula as conversion factors between moles of the whole compound versus moles of just a component for one ion. So in this practice problem, I wrote M like it's moles per liter, but we can rewrite that as moles per liter. So every time you see an M, you can cross it out and write moles per liter. And so I'll cross out that molarity unit as well and write moles per liter. Now let's look at our units. We have 2.5 moles of calcium nitrate. I can cancel out the calcium nitrate and say for every 1 mole of the compound, I'm going to make 2 moles of nitrate. And so my moles of calcium nitrate cancel out. Moles of calcium nitrate cancel out. And then I'm left with moles of nitrate per liter. And so since I'm left with both of those units, then my final unit is the molarity of one ion. All right, now we're ready to prepare solutions. This is like how you would prepare solutions in the lab. So there's 2 different ways that we could prepare a solution. And it really depends on what we have as our source of solute. So if we're starting with a solid, we can weigh out the mass of it on a balance. And so we could weigh that out on a balance. And then we'll have a container and we can empty it out into a volumetric flask. So this shaped flask is called a volumetric flask. Then now we have all this solid in here, and we're going to add some solvent. And so this is adding the solvent. That was adding the solute. After we add the solvent, we're going to swirl it to dissolve the solute. And then you see how there's only one line on here? We would continue adding until we made a certain volume of the whole solution. But if we pay attention to our units here, we're starting with a mass, which is often measured in grams. And then we're often interested in our molarity, which is moles of solute per liter of solution. And so my liters of solution, I can find out from where the line is. And so my flask will measure a certain volume of solution. But I have to be able to figure out my moles of solute. I can figure out my moles of solute from my mass. And so I need to convert my mass and get into moles. That way I can figure out my moles of solute. And to do that, I need my molar mass. Every time we need to use or convert between the units of grams and moles, I have to use my molar mass as a conversion factor. Let's do a practice problem. This says, what is the molarity of a solution containing 3.4 grams of ammonia which has a molar mass of 17.03 grams per mole in a 200 milliliters of solution. So what is the molarity containing this many grams? Go ahead and pause the video and see if you can figure out what the molarity is. Okay, let's go over this. It says, what is the molarity? So the molarity is defined as my moles of solute divided by liters of solution. That means I have to get this converted into liters. And this is my solute. And so I'm going to have to convert this number into moles. Now, looking at the units of molar mass, I can see the gram unit and I can see the mole unit. So that is my conversion factor between the units of grams and moles. So I can figure out my moles of solute by taking my 3.4 grams of ammonia, canceling out my grams, and getting into moles. The 17.03 is attached to the grams, and that is a 1 next to the moles. So my moles of solute is equal to 3.4 divided by 17.03, which is 0.19964 moles of NH3, ammonia. Next, I need to find my liters of solution. And so I am given 200 milliliters. And so I need to cancel out my milliliters and I need to get into liters. There are 1,000 milliliters in 1 liter. And so I'm going to divide by 1,000, move the decimal over 3 times, and I end up with 0.2, and then I have 3 significant zeros that I do not want to forget. Now I can calculate my molarity. Molarity is equal to moles of solute, so that's 0.19964 mole, divided by my liters, 0.2, with a bunch of zeros after it. And so divide that by 0.2000, and you end up with 0.9982. And then that's going to be in moles per liter, which is molarity. And I have to look at my sig figs. My mass only had 2 significant figures. So that's probably going to limit my sig figs to 2 sig figs. So if I try to round that to 2 sig figs, that 8's going to round up, and then that 9's going to round up, and then that 9's going to round up. Oh dear. And so that's going to round to 1.0 molar. So you can type your math there. Okay. So we could have also started with another aqueous solution. And so in this case, we are starting with a solution and we're diluting it by adding additional solvent in order to make it less concentrated. And so a dilution is adding extra solvent to decrease the concentration of a solution. What's important to note here is that when you're adding extra solvent, you're not going to be changing your moles of solute. That's just going to change your liters of solution. So that changes liters of solution, but your moles of solute don't change. So if we look at the units here, I have something that's going to help us calculate how many moles of solute we started with. And so in this flask right now, we have a certain volume, which is often measured in liters. That's my V1. You can write I for initial, so I have a certain volume, and that's measured in liters. And then I'm multiplying by whatever concentration that was. And so my molarity is moles per liter. And so the liters here are going to cancel out, and then I'll be left with my moles. And so my initial molarity times my initial volume is going to give me moles. Now, I know that moles doesn't change. And so over here in this container, I have the same number of moles of solute. And I have to figure out what its new concentration is or what volume it is now. And when we're doing practice problems, you're going to be given 3 out of 4 of the numbers, and then you have to solve for the missing number. And so here, I know that I have the same number of moles, and so again, I can use my units. Moles per liter is molarity, and then I can multiply that by the volume, and I'm going to have the same number of moles in the end. And so this is what we call the dilution equation. It's just, you can say it really quickly, M1V1 equals M2V2, and you can use initials and finals if you wanted to. Here's a practice problem related to that. It says, what volume of 12 molar potassium chloride is needed to make 5.00 liters of a 1.50 molar potassium chloride solution? And so this is my molarity. It's when you pronounce it, it's pronounced molar, but that is molarity. So here, that's my molarity. This is also a molarity. And so I can start matching up my initial and final conditions. And so I'm going to write initial, molarity initial, volume initial, and then molarity final, and then volume final. And so my initial molarity is 12.0 moles per liter. My initial volume, I do not know because that's what it's asking me for. Needed to make 5 liters is the final volume. Look at the unit, that's liters as a volume unit. And so my final molarity is 1.50 moles per liter. And so I can start with my molarity dilution equation. M1V1 equals M2V2. I'm going to use initials and finals. And so that says that my initial molarity times my final initial volume will be equal to my final molarity times my final volume. Because I know that if I multiply molarity times volume, I'm going to be left with moles. And so I know I'm trying to solve for my initial volume, so I need to divide both sides by my initial molarity in order to cancel that out. But it doesn't cancel out on that side. Is there an undo button? Okay, I don't think there's an undo. There's not an undo. Okay, so that doesn't cancel out. So that's going to simplify to V initial is going to be equal to M final times V final divided by M initial. I did not mean to cross that out. All right, so now I can plug in my numbers. And so I know that V initial is going to be equal to my final molarity, 1.50 moles per liter, times my final volume. of 5.00 liters. And then I'm going to divide that by my initial molarity of 12.0 moles per liter. When we do that, we're going to end up with 1.50 times 5.00 divided by 12. And so that is 0.625 liters. Now let's look at our units and our sig figs to make sure we're okay. Everything here has 3 sig figs, and so I do have 3 sig figs in my final answer. And for my units, that moles per liter will cancel with that moles per liter, and then I'll be left with liters in the end. Now we also need to make sure our answer makes sense. And so since we're starting with a more concentrated solution, we will need less of it in order to have the same number of moles as 5 liters in that lower concentration. And so the volume needed should be less than whatever volume we had of the lesser concentrated solution. So the volume needed should be less than 5.00 liters. And it is. And so that means our answer makes sense. And so if you type your math, you end up with the same thing. All right, colligative properties will be in a separate video.